All right, friends, a lot of what we're doing today is we're going to be doing practice right after we learn a new topic. So we're talking about that we can find the length of a line segment. Now, here's where we're going to have to start using our questions when we set up a problem. Is what do you have? Second question you're going to ask, where do you want to go? What do you want to solve for? And the third question is, how are you going to get there? Now you're thinking, Gregerson, these are so silly. But here I actually learned to solve and be a better mathematician in college when a professor kept asking me, what do you have? What information do you absolutely know? What are you looking for? And then she'd say it's okay to ask how or if questions, like how do I do this? If I do this, if I had this rule, would this work? And it was amazing how I could almost solve every math problem after that. So here we learn to read it. Now remember, they use bad notation. Drives me nuts. There should be a PT in front of here, but we're going to go with what the book has to save time. It says point M is between points N and O. Find the length, remember, that means length of segment NO. So I'm looking for that. Well, I look at my diagram now. Now, diagrams are really huge in geometry. It gives us a visual cue. They don't have to be drawn to scale. So I look at this and say, okay, I have two smaller segments, and they can add up to the larger segment. The nice thing is this diagram is already labeled, which makes my life easier. So I'm thinking, well, how can I solve for x? Well, that means I have to set up an algebraic equation. So what do I have? I have a line segment that's divided into two smaller parts. I want to find the length of the whole line segment. Well, how am I going to do that? Well, I have been introduced to the postulate, segment addition postulate, that tells me the sum of the parts equal the whole. So I go over here and I go, the parts can add up to the whole thing. So NM plus MO equals NO. So I'm going to literally go 17 plus 3x minus 5 is equal to 5x plus 2. And notice I substitute the information directly below it. Then, before I start, and please do this, it helps you not make errors, before I start switching sides, I make sure I combine like terms first. It helps me not lose track of positive and negative signs. Then I'm going to go ahead and solve. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So subtracting 2 from both sides, I get 3x plus 10 is equal to 5x. Now I'm running out of some space, so I'm going to move on to the other side. Now I want to get x by itself. So I subtract 3x from both sides. And for some of you, you might have to physically write that down. And there's nothing wrong with doing that. Show the work you need to do. So then I get over here, I get 10 is equal to 2x. Now remember, how do I solve now for x? Because I'm going to get the variable. X is equal to 5. Now I have to ask myself, where do I want to go? I want to get the length of line segment NO. I don't have it yet. I have x. But can I take x and substitute it in to find the value? Or actually, I'd probably substitute it into this one. It's a lot easier to find the value then. Yes, that's how I'm going to get there. I'm going to solve for x first, and then I'm going to substitute it in. And in fact, you'll hear me sing to you when a lot of times I have to plug the variable back in. I'll go, plug it in, plug it in. I want to make sure I'm solving it right, and I got to make sure most of the time I have to plug it back in. So here on segment NO, I know its value is 5x plus 2, so now I plug it in. I get 27. Kind of cool, isn't it? So the length of segment NO is 27. How do I double check? 3 times 5 is 15. Minus 5 is 10. 10 plus 17, 27. The sum of the parts did equal the whole. Now I'm going to look at the same type of idea here. I notice right away I have a line segment with sum of the parts labeled. And it says the following here. If the length of segment GJ equals 32, find the value of each of the following. I want to solve, so where do I want to go? I want to solve for the variable. I want to solve for the length of the two smaller line segments. So here's my question. How am I going to go about that? Well, one thing in geometry you will always learn with the how is you mark up your diagram. So I'm going to let myself know that whole thing is 32 units. So then I look at that and say, okay, if I have the two smaller ones and I know the length of the whole thing, do I have anything? How do I want to get there? Do I have anything that's going to get me to this? And I go, yeah, I know the segment addition postulate. The sum of the parts equal the whole. So I go 3x plus 16 is equal to the whole, which is 32. Combine like terms before I add or subtract. So I get 4x plus 16 is equal to 32. Subtract 16. You get 16. Divide both sides by 4. X is equal to 4. So now I got the fact that x is equal to 4. I got one of my steps. Now I'm looking for the length of segment GH. So how am I going to get there? That's right. Plug it in, plug it in. I'm going to plug it in for the value up here with it. So I got 3 times 4, so I'm going to plug it in for that x, which equals 12. Then I have HJ. I'm doing the same type of scenario here, and this is what I love about this stuff. I just plug it in, plug it in. That's how I'm going to do it. So I just go 4 plus 16 is equal to 20. So there is all the values. That's a problem-solving process that we did. But notice I marked up my diagram. You're going to see me do that much in geometry, and I'll get upset if you don't know how to do a problem if you didn't mark up the given information on the diagram. All right, we're going to keep on going, and we're going to use some more terminology that's going to be very important for you to know. Congruent segments. You all know congruency means the same. So if I have congruent segments, they are line segments, and if you want to put the word line above, that's totally fine. Segments that have the same length. So we have to use proper notation here. And proper notation is I can talk about their lengths being the same, and the inside I talk about the length, there's no bar. But if I also want to show they're congruent, or we state that they're congruent, we have to use a congruency symbol. And that congruency symbol is an equal sign with kind of like a similarity symbol over the top of it, or the Coca-Cola wave is like what I like to call it. So this symbol right here, that means same size, same shape. Right? Congruency means same size, same shape. So it reads segment PQ is congruent to segment RS. So this is how you use notation. Make sure you can see that. For congruency. Now I have to be able to mark that in diagrams. It's really huge that I be able to mark it up. So in geometry we have to have some way of doing that, and we use what are called tick marks. The same number of tick marks on a line segment means that they're the same size. So here I have 1 tick mark each, so you know segment PQ and segment RS are the same size. Now if you wanted to put 2 tick marks down, all power to you. There's nothing wrong with that. So we just got to make sure that you understand those. So we're going to use this idea of congruency in a little bit to solve some problems. So let's flip the page over and let's get some more information.